Hey everyone, welcome back to Shah Teaches Computer Science. I'm Shah and this is CSC 100 Introduction to Computer Science. Today we're kicking off the course with the big question everyone thinks they already know the answer to. What is computer science? Spoiler, most people get this wrong. And by the end of this lesson, you're going to understand why, and you'll actually be able to explain what computer science really is, not just what it looks like from the outside. Let's get into it. So let's start with a working definition. Computer science is the study of computers and computing, but that's just the surface. It includes the theoretical and algorithmic foundations behind computing, the hardware and software that make it run, and how all of that gets used to process information. Notice that word theoretical in there. That's important because a huge part of computer science has nothing to do with touching a keyboard at all. It's math. It's logic. It's problem solving on paper before a single line of code gets written. Throughout this course, we're also going to build up a glossary of computer science terms, the vocabulary of this field, because just like any discipline, computer science has its own language. And once you know the language, everything else gets easier. Before we go further, here's what you're actually going to walk away with by the end of this lesson. I like to break this down into 3 levels. Attitude, you're going to develop your own personal view of what computer science really is. Not just repeat a textbook definition, but actually understand it enough to explain it in your own words. Skill, you're going to practice integrating different computing tools and resources to tackle complex problems while understanding their limits. That's a skill you'll use in literally every course after this one. Knowledge, and very concretely, you're going to build a glossary defining the common misconceptions about computer science. That's actually one of your activities today. So keep that in mind as we go. I want to start with this quote, often attributed to Einstein. Computers are incredibly fast, accurate, and stupid. Humans are incredibly slow, inaccurate, and brilliant. Together, they are powerful beyond imagination. Sit with that for a second. Computers don't have creativity. They don't have judgment. They just execute instructions extremely fast and with 0 mistakes. As long as those instructions are correct, humans, on the other hand, are slow and messy, but we bring creativity, intuition, and judgment to the table. Computer science, at its heart, is the discipline that sits right in between those two things. It's how we take human ideas and translate them into instructions a fast, stupid, tireless machine can execute perfectly. Keep that image in your head, it's going to come up again and again this semester. All right, let's tackle the misconceptions. Because almost everyone walks into this course with at least one of these in their head, and that's totally normal. Misconception number 1. Computer science is the study of computers. Sounds obvious, right? It's literally in the name. But this is incomplete. Here's an analogy I like to use. Astronomy uses telescopes, but astronomy isn't the study of telescopes. The telescope is just the tool. In the same way, the computer is the tool computer scientists use, but the discipline is much bigger than the machine itself. It's about problem-solving algorithms and information, and the computer just happens to be how we execute those ideas. Misconception number 2. Computer science is the study of how to write computer programs. This one trips up a lot of beginners, because programming is usually your first hands-on experience with the field. So it feels like the whole thing, but programming is really just the entry point, the doorway into the discipline, not the discipline itself. Think of it like this. Learning grammar and vocabulary doesn't make you a novelist. It's a necessary skill, but it's a tool for expressing much deeper ideas: algorithm design, problem solving, computational thinking. Programming is how we express computer science. It's not computer science on its own. Misconception number 3. Computer science is the study of the uses and applications of computers and software. This comes from seeing professionals in every field: doctors, accountants, engineers, artists, using computer packages and software every day. And sure, that's a use of computing, but knowing how to use Excel or Photoshop doesn't make someone a computer scientist, any more than knowing how to drive a car makes someone a mechanical engineer. Using an application is consuming computer science. Building the underlying systems, algorithms, and logic that make that application possible. That's actually doing computer science. Now, here's the important nuance. None of these three misconceptions are wrong, they're just incomplete. Computers, programming languages, software, and applications are all genuinely part of computer. Here's the definition I want you to actually remember from this lesson. Computer science is the study of algorithms, and that study breaks down into four areas: their formal and mathematical properties, their hardware realizations, their linguistic realizations, and their applications. Let's go through each one, because each of these is actually a whole subfield of computer science on its own. First, their formal and mathematical properties. This is about studying the behavior of algorithms to determine whether they're correct. Do they actually solve the problem they claim to solve? And whether they're efficient. Do they solve it in a reasonable amount of time and using a reasonable amount of memory? This is the theoretical side of CS. It's the math-heavy, proof-based side. Think of fields like algorithm analysis and computational complexity. This is where those come from. Second, their hardware realizations. This is about designing and building the actual computer systems capable of executing these algorithms. Someone has to design the circuits, the processors, the memory systems that physically carry out the logic. This is where computer engineering and computer architecture, which we'll cover later in this course, come into play. Third, their linguistic realizations. This is about designing programming languages and translating algorithms into those languages so the hardware can actually execute them. This is where things like compilers, interpreters, and language design live. Every programming language you'll ever learn, Python, Java, C++, exists because someone did this work. And fourth, their applications. This is about identifying real, important problems in the world and designing correct and efficient software to solve them. This is the piece most people already associate with computer science, but now you can see it's just one of four pillars, not the whole field. Since we just said computer science is the study of algorithms, we need to actually define that word properly. An algorithm is a procedure for solving a problem in a finite number of steps. And more broadly, it's simply a step-by-step method for accomplishing a task. Notice a finite number of steps. An algorithm has to actually end. It can't run forever. That's a small detail now, but it becomes really important later in this course when we talk about things that can't be solved algorithmically. Here's the generic shape of every algorithm you'll ever write. Step 1, do something. Step 2, do something. Step 3, do something. All the way to step N, stop, you're finished. That's it? That's the skeleton. Every recipe, every driving direction, every piece of software you've ever used follows this exact same pattern underneath. What makes algorithms interesting is what kind of steps go inside that structure, which brings us to our next point. Every algorithm, no matter how complex, is built from just three categories of operations: sequential operations, conditional operations, and iterative operations. These three building blocks are the foundation of all programming, and I mean all of it. Once you understand these three, you can read and write logic in any programming language. Let's break each one down. Sequential operations carry out a single, well-defined task, one after another. They're usually expressed as simple declarative sentences, just plain statements telling the computer to do one specific thing. For example, add a cup of butter to the mixture in the bowl. Or, subtract the amount of the check from the current balance. Or, in programming terms, set the value of x to 1. No decisions being made here. No repeating, just one instruction, then the next in order. Conditional operations are the question-asking instructions. The computer checks a condition, and based on the answer, it decides which path to take. For example, if the mixture is too dry, then add 1/2 cup of water to the bowl. Or, if the amount of the check is less than or equal to the current account balance, then cash the check otherwise. Tell the person there are insufficient funds. Or in code logic, if x is not equal to 0, then set y equal to 1 divided by x. Otherwise, print an error message that you cannot divide by 0. This is where decision-making enters your algorithms. This is the if this, then that logic you'll use constantly once we start programming. And finally, iterative operations, the looping instructions. This is where you go back and repeat a block of instructions, often until some condition is met. For example, repeat the previous two instructions until the mixture has thickened. Or, while there are still more checks to be processed, do the following 5 steps. Or, repeat steps 1, 2, and 3 until the value of y equals +1. Sequential, conditional, iterative. Write those 3 words down. Every algorithm you build this semester, and honestly for the rest of your career, is some combination of these 3. All right, time to put this into practice. I've put a short activity in the quiz below this video. Go ahead and pause the video, complete it, and come back. It directly reinforces what we just covered about misconceptions and the true definition of computer science. So, quick recap. Computer science is not just the study of computers, it's not just programming, and it's not just using software. It's the study of algorithms, their math, their hardware, their languages, and their applications built from 3 simple ingredients: sequence, condition, and iteration. That's it for Lesson 1 of CSC 100 Introduction to Computer Science. If this helped, hit like, subscribe for the rest of the course, and I'll see you in the next lesson where we go into the brief history of computing. Thanks for watching. This has been Shaw Teaches CS. Thank you and God bless you all, my dear students. See you in the next video. Bye.